guys, so I'm going to be teaching today how to do a topic in calculus called trig substitution. And let's take a look at this example of an integral. For example, how would we find the integral of the square root of 25 minus x squared? Let's say like you're an engineer and you're designing part of like a circular ramp or a bridge, and you want to find the area of this section of it. The equation of a circle is going to be something like x squared plus y squared equals 25. And then when you solve for y, you're going to have something like this, 25 minus x squared. And if you want to find the area of under that bridge, you would need to integrate. And the only way you can solve this is by using a technique called trig substitution. And basically you just take your x and you substitute it for a trig function in terms of theta. So for example, in this one we have root 25 minus x squared dx. And let's take a look at we have this form here, a squared minus x squared. And when we have this form, we use a substitution of x equals a sine of theta. And our a value is the 25 in this case. Our a squared value is a 25, and if a squared equals 25, then a equals 5. So now x equals 5 sine of theta. We make the substitution. 25 minus 5 sine of theta, all of that squared. And the issue now is, since we did a substitution, we have to find this. Since this was in terms of dx originally, we are now in terms of d theta. And in order to balance it, we have to find what our d theta is. And so we take the derivative of the x equals sine, the x equals 5 sine theta, and that would be just 5 cosine theta d theta. So dx equals this, so we just write on, I'll rewrite it down here. This is now 5 cosine theta times this d theta. And now we can start to simplify what's under the square root, because the goal is you need to be able to get rid of the square root, otherwise you're never going to be able to integrate it. So what we do is we rewrite this as integral 5 cosine theta, and then on the inside the square distributes, so you have 25 minus 25 sine squared theta. And we can turn this into 5 cosine, integral 5 cosine, this is all d theta, theta root. Inside the root, we can factor out a 25 25 times 1 minus sine square root of theta d theta, and this turns into this 1 minus sine squared theta just turns into cosine squared theta. That's the Pythagoras identity. So now this is 5 cosine theta, and this would be 25, square root of 25 is 5 times cosine, sorry, get rid of the square root. We can get rid of the root now because this would just be these are both perfect squares. The whole thing just, or the 25 is perfect square, and this is going to be squared. So the square root and the square will go away, and you're left with cosine, 5 cosine of theta d theta, and these are multiplied together. So now I'm going to rewrite all of this. As the integral of 25 cosine squared theta d theta. And now we know this is much easier to integrate than when we had the root. What we can do is just take out the 25 to the front. And okay, so when we have this integral of cosine squared theta d theta, you can't do a u sub because of the square, but cosine, there's a rule that says cosine squared theta equals 1 plus cosine of 2 theta over 2. So now this can be rewritten now. This equals 1/2 plus cosine of 2 theta over 2. And when you have an addition here, we can split up into the integral. So this turns into now, we're going to make sure that we don't forget to keep the 25, integral of 1/2 d theta plus integral. Remember, keep 25 because this would be distributed of this. Actually, this part here can be written as 1/2 of cosine squared theta, which means I can bring the 1/2 out. So now this is just 25 over 2 cosine 2 theta d theta. Okay. And now this just turns into 1/2 theta, and this one we're going to do u sub. You set u equal to 2 theta, du is now 2 d theta, and then so I was just going to bring another 1/2 out. This will turn into 4, 25 over 4. I'm just going to drop the integral now. Or not yet, but 20, I want we'll write this in terms of u now. So this is now integral of cosine of u. Okay, so integrate turns into minus sine minus sine of 2 theta, and this is now going to be 25 over 2 theta. So then minus, make it a little cleaner with this. And now that would be our integral, but this is in terms of theta. and we need it actually in terms of x. But we remember up top, x equals 5 sine of theta. Then that means, okay, so x equals 5 sine theta. Then sine of theta equals x over 5. We draw a right triangle, set this angle at theta. Sine is opposite over hypotenuse. And then, oh, we actually don't even, we just need to find theta. We don't need to even make the right triangle for this case. Just that this would be double here. So we do need to find theta though, because we have 25 over 2 theta. How we find theta is just an inverse sine of x over 5 equals theta. So it's okay, 25 over 2 sine, or arc sine, inverse sine x over 5 minus 25 over 4 sine. We're going to multiply by 2. Or you could use a double angle formula, which I'm actually going to do instead. Low key. Okay, so we know that sine 2 theta equals 2 sine theta cosine theta. I don't think you can just multiply by 2. Let's do it like this instead. So we do need the right triangle to find the cosine then, in this case. Theta opposite over hypotenuse. You know this side, we need this for cosine. This is going to be 5 squared equals x squared plus a squared. The a is this side. So 5 squared minus 25, or minus x squared equals a if we root this. So now we know our cosine is going to be cosine theta equals root 25 minus x squared over this, and the sine theta equals x over 5. Plug that into here. So this is this here. Let's rewrite it. I'm just going to skip a step and write it straight as 2. So there's a 2 up front. I'm going to just multiply the 25 by 2. That is in a 50. And then sine theta is x over 5. And then cosine theta is root 25 minus x squared over 5. Plus c, and I'm just going to write this theta here. So this 25 over 2, this part 25 over 2 sine inverse, sine inverse x over 5 and that's the final answer in terms of x.
Alright, let's look at some trig sub integral integration. Okay, so for trig sub, there's going to be, honestly, the most important thing to remember is the 3 forms that you need to remember to look out for when you are integrating. You, if you know these 3 forms, you pretty much can do almost every type of every type of trig sub problem in Calc 2. And these are the 3 forms. If we see something like this, you're going to need to do a sub with x equals for an a squared plus x squared, x equals a tangent theta. For x squared minus a squared, x equals a secant theta. And for a squared minus x squared, x equals a sine theta. If you know these three, you will be pretty much fine. Again, these two go together, these two go together, and these two go together. So, other than that, knowing your Pythagorean identities and knowing SOHCAHTOA, those are going to be necessary when you're dealing with like right triangles. Specifically when you inevitably have to convert your antiderivative, which is in terms of theta, back into terms of x, you're going to have to look at the ratios of like a right triangle. Let's say we have something like x equals 3 sine theta, and let's say your antiderivative is theta. How can we get this in where you change this into? Or how about this? Let's say you have cosine theta. How can I find cosine theta when I'm given this? Let's say, okay, we need to rewrite this in a way where we can apply this right triangle and SOHCAHTOA to help us. So we can rewrite this here as sine, and I will remove all of these. I don't need that anymore. Oops. So yeah, we can rewrite this as sine theta equals x over 3. So sine, you're always going to be dealing with the sine of this angle. SOHCAHTOA uses the opposite over the hypotenuse. So this is our opposite, this is our hypotenuse. So x over 3. We can use Pythagoras theorem, a squared plus b squared equals c squared, in order to find this missing side. Let's say this is a squared, and this is our c squared, this is hypotenuse. This is our b squared. Okay. So if a squared plus b squared, so this is b squared. I'm sorry, let's say this side is oops. This side's a, actually, this side's b, and this side's c. A squared, this is the side that we're solving for. This is our b, so x is b, so b squared is x squared equals, so c, in our case was 3, so 3 squared is 9. To solve for a squared, it's really just going to be 9 minus x squared equals a squared, and then root 9 minus x squared equals a. Oops. So we know that this side, a, is root 9 over x squared. So now we have this, and then at the beginning I said we wanted to, let's say our antiderivative in the end was cosine theta. Then cosine, we know from SOHCAHTOA that cosine is just your adjacent side over your hypotenuse. 3, so cosine of theta equals 3 root 9 minus x squared over 3. So you would make the substitution if say your antiderivative was cosine theta. Change cosine theta into root 9 minus x squared over 3. So again, I'll rewrite it all. If our x over 3 equals sine theta, then cosine of theta equals, we know that this is going to be 9 minus x squared over 3. And this, if say you got this as your antiderivative, then you would just replace it with this in the answer, plus c. That's something that's just fundamental for remembering when we're doing our trig sub questions. Also, we need to be remembering a couple very important Pythagorean identities, specifically these two. Sine squared x plus cosine squared x equals 1, and tangent squared x plus 1 equals secant squared x. These are going to be pretty much all-encompassing when it comes to trig sub because of our 3 forms that yield a sine theta as a substitution, a secant theta, and a tangent theta. So you can see how you can use these in order to simplify whatever you have under your square root, because obviously when we have an integral of say dx over something like this, or an integral of 25 minus x squared, something like this, we can't do a u sub, or we can't use previously known integration techniques to solve these specifically because of this square root. It just really complicates things, and you're going to need to be able to identify these forms. In this case, we have a squared minus x squared for both of them, but you could have a squared plus x squared, or you could have a situation where you have x squared minus, say, 36 in your integral, and this one would be a secant case. Again, the most important tips for our trig sub problems is always going to be remembering our 3 most used forms, and knowing when to apply which one, and knowing all of our identities, and knowing how to change your antiderivative in terms of theta to in terms of x. And let's see what else. I guess we should do an example question. Okay, yeah, so do a quick example. So let's say we have integrate this. So we know we're going to form a squared minus x squared. Our a is going to be 4. So we use the x equals a, or in this case x equals 4 sine theta substitution for these. This correlates with this sign here. Make our substitution. 16 minus, this is our x, so we replace it here, 4 sine theta squared. Now we can distribute the square. We also need to make sure that we're in terms of theta. So we have to solve for our d theta. This is also probably the next most important thing about these. We have to make sure that we are doing our substitutions correctly to match from when we have dx to now we need to be in terms of d theta. Oops, this is actually, I'm getting confused. Let me rewrite this. So this is actually going to end up being 4 cosine theta for radical 16, and I'll just square that real quick. So minus 16 sine squared theta, all that times d theta. Yeah, differentiating between our dx and d theta, obviously, you have to account for the difference between dx and d theta, and when we make our substitution, we get a 4 cosine theta here. Now we can factor out the 16. The 16s from both of those terms in the out of the radical, and we get 4 cosine theta stays the same, and in the radical we're gonna have like 16 times 1 minus sine squared theta d theta. This is actually just by this is the identity. This is gonna be now. Oops. Cosine squared theta, and this radical can go away now because we have this perfect square 16 here and this perfect square cosine squared theta here, and this is our goal when using trig sub, get rid of the radical. This is now just going to be 4 cosine theta times 4 cosine theta, and the d theta stays there too. Just like that. These equal each other, and now in this case the next step is going to be to use another identity of trig that you have to know. But first, let's multiply these together. X. And this is going to look like, we can take out a constant of 16. And this is going to look like integral cosine, like this, of d theta. And the problem is now, obviously we cannot do a u sub here, because we have the square term. So what we're going to do is rewrite cosine squared theta using a rule that is cosine squared theta equals 1 plus cosine 2 theta over 2. This is where these problems can get a little bit tricky, because if you don't know this, then you're going to be stuck here, and you will, most of the work's already done. You've successfully done trig sub, but now you don't know how to integrate this. If we rewrite it like this, then this also can be rewritten like 1/2 plus cosine of 2 theta over 2. And if we have an addition with integrals, you can always remember that you can split this into 2 separate integrals. So we'll write the first one. 16 integrates 1/2 in terms of d theta, make sure you keep it in terms of d theta, and then plus 16. The 16 would get distributed. That's why it happens twice of a cosine. And we're actually, this is like the same as 1/2 times cosine 2 theta. So we can take out the 1/2, make the 16 over 2, or just 8. 8 integral cosine 2 theta. So then we can further use another identity on this, which is the double angle for cosine of 2 theta. Or we can just do a u sub. I think that in this case, I'm going to use a u sub for 2 theta. I think there's a double angle for it, but I think this is going to be the best way to do this. 2d theta. Okay, so this u sub just turns into 4 integral cosine. It's just negative sign. U. There you go. We write it all now. 16 radical 1/2 d theta. Or radical, sorry, 16 integral of 1/2 d theta. Let's say this is going to be pretty simple. This is like, we can also take out 1/2 if we wanted to, and just change this to 1 d theta, or just d theta. And this is going to equal 8 times theta. So 8 theta plus, sorry, minus actually, 4 sine of 2 theta. And that's our antiderivative in terms of theta. You're going to want to, obviously, you're going to want to turn this into, in terms of x. What did x equal in the beginning, our original substitution? X equaled, was it 4 sine theta? Yeah. Which means that sine theta equals x over 4. Which means our theta equals, like from, theta is going to be inverse sine of x over 4. So that deals with this theta, but we also have to know what sine of, well, we can actually just leave it like this, but I think it would be better to get rid of the whole trig function. Like I could just plug in theta here, but then you have sine of an inverse sine, and it's kind of weird. So instead, let's draw a triangle. Actually, we have sine of 2 theta, so we're going to use a double angle for sine sine of 2 theta equals 2 sine theta cosine theta. We need a right triangle. If this is theta, sine of theta, we have our hypotenuse of 4 and our opposite side of x. This is just going to be rad 4 minus x squared. You can double check that in your head, or you can think about it. X squared plus a squared equals 16. So this is actually, yeah, good thing I double check that. 16 minus x squared here. And all in all, we have our sine now, we have our cosine theta now. Let's put it all together for final answer. 8 theta is our theta, 8 is sine inverse x over 4. Cool. That part's done now in terms of x. Minus, so this is minus 4, but we also have a 2 here. So 4 times 2 is going to end up being 8. Sine theta is x over 4. So make sure you multiply the whole thing. Actually, it doesn't matter. But we'll just do it like this anyway. Yeah, okay. Sine x over 4, and then our cosine is our adjacent that we saw for over our hypotenuse. Root 16 minus x squared over 4. Oops. Plus c. You can simplify this further. I'm not gonna. That's your final answer in terms of x. This all up here. And that's about it for trig sub. Again, it's just a lot of knowing your stuff, understanding your trig identities, memorizing them, the Pythagoras ones, the double angles. There's ways around not knowing them sometimes there really isn't. All right. And yeah, thank you for watching.